All right, let's now go over some slides. Okay, so this slide is very important. It's a little bit abstract, so many bullet points to actually go over. Let's go over them. I'll read them together with you, and then I'll try to make some connection to some diagram just to help you understand. Let's review what a data type is. A data type simply denotes a set of related runtime values. Okay, and then, for example, here, every class can be used as a type, the set of runtime objects. So this actually is a very important concept I would like to just emphasize again. Let's say this. So let's say if I got something, some decoration like this. Let's say if I say iPhone, let's say 13 Pro. So this is one of the classes I just spoke about, right? iPhone 13 Pro over here. If I declare some variable, let's say my phone. Let's now just review what we should know already. So iPhone 13 Pro, so this is so-called a static type, or just type, declare type. Declare type, or static type. So what that means is, at runtime, my phone variable may store the address of some iPhone 13 Pro. However, I want to be a little bit more careful over here. So because inheritance hierarchy might grow further, meaning that, well, not in this case, but iPhone 13 Pro may actually later on maybe have some specialized kind for iPhone 13 Pro. Maybe you have some special configuration for the phone, but it's not really shown over here. So I would rather say iPhone 13 Pro compatible. And what do I really mean compatible? You will see the rule later when we go over them. Okay? I'll just say compatible. So iPhone 13 Pro compatible objects. So this is really corresponding to what I meant over here. Every class that's used as a declared type, so they simply refer to a set of runtime objects, because here my phone can actually simply store the address of some iPhone 13 Pro compatible objects. So it is really a range of choices for you at a runtime. Any objects that's actually iPhone 13 Pro compatible, you can definitely store their address into my phone variable. Okay. Okay, the use of inheritance creates a hierarchy of classes, right? Hierarchy you can see like this, right? Hierarchy simply means there is a notion of higher and also lower, right? That's what we meant by hierarchy. And hierarchy actually is very common practice, not just for artifacts, but also for human management as well. For example, in a university or in a company, you also got a hierarchy. Maybe from the CEO, from down to manager, and also down to some team leader, and down to some basic level employees, right? So that's a hierarchy, which is very useful, a very important notion to actually understand. Okay, so in the implicit root of hierarchy is simply just objects. Okay, so that's something I also mentioned earlier when I talked about the equals method. Implicitly, every class actually extends from the object class, but we typically don't draw that. That will just create, just make your diagram too messy. So if I really wanted to draw, I could draw something like this. I can say the smartphone also inherits from. Okay, actually, just draw an arrow like this. Okay. I can definitely do another arrow over here, and then like that. And this will be simply the object class. And more to it, you can also think every class, well, once the top of the hierarchy over here actually extends from objects, implicitly you can think about iOS, because iOS extends from smartphone. And also smartphone extend from objects. By the property of transitivity, we know that iOS also implicitly extends from objects. So if you don't really need to have to just draw another arrow to say iOS extends from objects. You don't need to. As long as you know the top of the hierarchy actually extends from objects, every subclasses over here, they also implicitly extend from objects. That's something I want to mention. Okay, let's now go further. Each extends decoration corresponds to an upward arrow, right? You can see this arrow over here simply means some extent. It's also very important for you to note. Okay, I just draw that again. For example, this one here, right? It's an arrow. It simply means extends. Accordingly, if you look at this diagram over here with so many arrows, you might be expected to actually create Java implementations from there. For example, you might have to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 classes. And then for each one of them, you have to put in the appropriate extends phrases. For example, you would say Huawei P50 Pro extends Huawei. And also Huawei extends Android. Android extends smartphone. Right? So that will be some extra exercise for you to actually create the Java implementation according to the design architectural diagram. That's also some exercise for you. Let me put it down. Exercise creates Java classes implementing this type hierarchy. Okay, it's a simple exercise, but it can definitely it's actually important for you to actually complete. Okay, let's now move on. The extends relationship is transitive when A extend. Okay, that's well, as I said before. Let me just say it again. For example, iPhone SE extends iOS. iOS extends smartphone. So that means iPhone SE implicitly or indirectly extends smartphone. Right? That's transitivity, and that's kind of analogous to what we learned from the elementary school. If you say A larger than B, and also B larger than C, so what does that imply? That implies A larger than C, right? It's exactly natural for us to think that way. Okay, so that's why it's transitive. All right, and so that's why every class implicitly extends the object class, as I explained. Let's now talk about two important notions between ancestor and also descendant classes. Let's take a look at the definition, and then we'll actually see one exercise, for example. The ancestor classes, usually multiple, of a class A are, it's important to know that A itself is also A's ancestor. It sounds a little bit weird, but I would say for our definition for the substitution rules later, so always remember for either ancestor or descendants of a class, they both include the class itself. That is important to note. It'll be A itself, and also all classes that A directly or indirectly extends. Let's see a little bit more abstract diagram. Let's see A is actually over here. So if you want to define the ancestor, basically what you have to do is you got to follow the extends arrow over here. One, so that'll be parents, and also follow again grandparents, and also all the grandparents all the way up to the root of the hierarchy, right? So it's also again important for you to know that this is the root of the hierarchy here. So when you want to find the ancestor, you want to trace all the way up to the ancestor, all the way up to the root of the hierarchy. So this will be the root of hierarchy, or you can say top if you prefer. All right. So now in this case, how can we find out the ancestor for A? So basically, you will find out for ancestor. Let me use green. Okay. For ancestor, it's going to be this one here. The parents, and also the grandparents, and all the grandparents all the way to over here. The green ones are actually the ancestors for A. Okay, so that they will be the ancestor. And one thing I forgot to actually also circle or to highlight, A itself is also A's ancestor. Just don't forget. Okay, so let's now try to make it complete. So here, you can see here, all the way up to the top of the hierarchy. So this part over here will be the ancestors of A. Okay, let's now see what's so important about ancestor of A. A inherits all the code, basically all the non-private attributes and methods from its ancestor classes. So let's think in this way. A inherits all the code. When I say code, I really meant the non-private attributes and methods. A inherits all the code from its parents, and this parents also inherits all the code from its parents over here. Indirectly, A also inherits all the code from its grandparents, and etc. So if you actually continue with such reasoning, you will know that A inherits everything from here, and all the way up to the root of the hierarchy. So that's really what I meant. Okay? It's really important to see that. So that's why accumulation of code is a very important concept you have to know before, and that also has to do with expectation, right? And once you know about the expectation, you will be able to understand polymorphism intuitively. Okay, A's instances have a wider range of expected usages, like more attributes and methods you can call, than instances of its ancestor classes. For example, let's say, just for example, let's say here, tentatively, let's say we got method M1 over here, and here, let's say we declare a method M2, method M3, and also in A, we got method M4. In this case, let's say, let's just say for this class over here, what's the expectation for this class? The expectation will just be M1. Agree? And what about this one here? This the expectation will just be, let's say there's no new methods in between. So that will be M1 and M2. M1 and also M2. And what about this one here? And the expectation will be M1, M2, and also M3. And this one here is going to inherit everything. It's going to inherit M3, M2, and M1, and also including the new method it declares. So expectation will be M1 all the way to M4. M1, M2, M3, and also M4. So that's about the accumulation of code of attributes and methods. They are actually non-private. All right. Symmetrically, we can also declare descendant classes of a class A. So let's see what the definition is. A itself. So that means A is its ancestor and descendant at the same time, simultaneously, just for definition. So A itself and all the classes that indirectly directly or indirectly extends A. Okay, let's now take a look. In this case, how can we do that? How can we visualize that? You can see this will be directly extends this is one class that directly extends A. So this is just the other class that directly extends A, right? Just for in this particular example. So these two should be included in the ancestor. Okay. And the reason that I'm drawing some triangle over here, this simply means all the classes that actually extends under this particular class. So they should be included as part of the A's descendants. And also similarly, all the classes under this particular subclass of A, they should be included as A's descendants as well. And also A itself. Okay, let's now see. A itself, right? A itself should also be its descendants. So now let's now circle properly. You can see this part over here, including A. So this part here is going to be the descendants of A. Right? It's very important concept. And you can see the intersection between ancestor and also descendants is A itself. Okay, just by definition. Let's now take a look. And it's not surprising to claim that code defined in A is inherited to all its descendant classes, right? You can see here, whatever you define in A over here, for example, M4 is going to be inherited and made available to all the classes underneath in the hierarchy. Okay, or put it in this way, the lower the class is in the hierarchy, the more code is going to accumulate from its ancestor. Okay, let's also make that conclusion. Okay, so now if you go in this way, so we say this part is the higher part of the hierarchy, and this part here is the lower part of the hierarchy. The lower the class is, the more code, i.e. attributes and methods, inherited from ancestors. And since you got more code inherited, you got wider expectation, bigger expectation. Wider. Oh, let me just write a little bit better. Wider expectation. And if you argue the opposite way, it will also apply. So that means the higher the class is, the less code you will be inherited from its parents, right? Because especially the extreme case would be, let's say this one here, and for this class over here, the only class it inherits from will be the object class implicitly, nothing else. So that's why you will get the least code available. So that means you got the narrow, their expectation will be narrower. It's a kind of relative. Okay, so that's about this slide. You can see quite much information that's set over here, but I'm just trying to use a diagram to help you. Okay, I would say let's do one. Okay, that will be the next topic. But let's now do one exercise together. Okay, and just to conclude all the abstract point that we just made.